points on the Cartesian plane can only be considered collinear if the slopes pertaining to those points are the same. In this case, for these first three pairs of points, if the slope of a line containing AB is equal to the slope of a line containing BC, and also equal to the slope of a line containing AC or CA, then the 3 points are considered to be collinear. To do this, we are going to show the slope as this formula. The change in y sub 1, or change in y, denoted as y sub 2 minus y sub 1, and x sub 2 minus x sub 1. So the first three sets of points, let's try to show if they are collinear. So we have the slope of AB. Let's use B as our second point. So you have here negative 7 minus 3 over negative 4 minus 2. So the slope here is negative 10 over negative 6, or in this case, this is positive 5/3. Now let's have the slope of BC. We have here C as our second point. You have 8 minus negative 7. You have here 5 minus negative 4. You will have here, that's 8 plus 7, that's 15 over 9. In lowest terms, it is also 5/3. And finally, for the slope of line containing A and C, C is our second point, 8 minus 3. You will have here 5 minus 2. So we have here 5 and 3. So 5/3, all the slopes are the same. In short, the first set of points are collinear. Let's also verify the next three sets of points, D, E, and F. So the slope of DE is computed considering E is our second point. You will have 1 minus negative 1, and then over, you will have here 1 minus 2. This is 1 plus 1, so 2 over negative 1. So the slope here is negative 2. For the slope of E and F, making F as our second point, we have 4 minus 1 over 3 minus 1. This is already 3 over 2. Notice here that the points do not share the same slope, regardless of whether the third slope would be either the same as the first and the second. But for collinearity of points, all the slopes must have the same value. In this case, for the next set of 3 points, the points are non-collinear. This is since the slope of a line containing DE is not the same as the slope of the line containing E and F.